So, hello, welcome all who have joined the meeting. I can see a raised hand. Yes, Raymond, you can unmute so I can see you've raised your hand. Yes, pardon, I can't hear you. Can everyone hear me well? Can everyone get to hear me? So, before we even start, I would like to know how many are familiar with the kariRS framework, or how many have experience. Let's start with how many have an experience in writing embedded code. Sharon, could you please unmute your mic? And what embedded code have you written? Is it in kariRS or Arduino, or what? Where have you interacted with embedded programming?
I have interacted with embedded programming
Yes.
with Arduino,
Yes.
for a bit of Rust
Yes.
for embedded.
Yes.
Yeah, that's about it.
Okay. Okay. That's nice. Which microcontrollers, to be specific?
ESP32,
Yes.
the Arduino Uno,
Yes.
and I also did something with the ESP32, the one that has a camera.
Oh, okay. I see. So you've mentioned that you've written programs in Rust.
It was simulation,
Oh,
trying to light an LED.
yes.
On Woki,
On which microcontroller?
it was an ESP32 simulation,
Okay.
trying to blink the LED on it.
Okay. That's good. Anyone else who has who has experience with embedded programming? Even if it's just you've just interacted with it once. Anyone? Okay. So I think I can start from there. Although our main topic today will be dealing with an LCD displays, and to be more specific, I2C. So first, for those maybe who have not even seen an LCD display, let me sh- let me let me sh- let's just do very fast and see what it looks like. Uh, so everyone can see my screen clearly. Can everyone see my screen clearly? Someone just to confirm. Okay, thank you, Sharon, for confirming. So usually this is how an LCD display looks like, and they come in various forms. So this is how an LCD display looks like, and it has various pins for connection. But our main focus here will be using an I2C, which will be understanding what is I2C. So you can see this module here, this one. This one is known as an I2C module. This one, you can see it. It's the one that connects to the LCD with all these pins, and then it simplifies the communication to give you just the I2C communication protocol, or it enables you to communicate with this display via I2C. So the first thing is to ask ourselves is what is a protocol? So I want to, if you've not interacted with the LCD displays, I want you to first have a glimpse of what literally happens when we want to make to display characters in such a module or in such a display, because understanding just this one will make you even work with other types of displays. So let's first understand what is a protocol. So a protocol is generally how you do things. We could also, if you could look at the dictionary definition of that. I think I had checked it for you here. Let me. We have this I2C communication, but you can go ahead and check uh, what is a protocol. So literally by the definition, you see that a protocol is a set of rules or guidelines for communicating between devices. So it's how devices communicate with each other, how your display will communicate with a microcontroller or any other device, how devices actually just communicate. So there are various types of protocols which are used for communication, but our for us today, we'll be looking at I2C communication, and furthermore, how it is used in LCD displays and how to use it in kariRS. So I2C protocol, communication protocol itself is a whole topic. It's a topic that you can read about it and understand how it works. But basically, I've just Googled here so that everyone can be on par. So you can see that I2C is a widely used two-wire serial communication protocol designed by Philips in 1982 for short distance, low speed data exchange between integrated circuits. It is also known as two-wire interface. So some people, you'll find it uh, being known as two-wire. Some libraries or frameworks you might use, you might find it being referred as TWI, that is two-wire interface. And the reason is because it uses two lines for communication. It has two lines, or the way you would like to, if you want to just simplify it, you could say it's two data lines. So we have the serial data and the serial clock. And as I mentioned, the I2C communication protocol is a big topic. It's more than even what I'm showing you here. It's a whole topic by itself. But we just be checking on how we can interface or communicate with LCD displays using the I2C communication protocol. So, but if you are completely new, you can later just dive into checking how the I2C communication protocol works in deeper terms. But literally, these just this should be enough for you to be able to just to initiate communication using I2C. Just understanding that it uses two data lines for communication. We have the serial data and the serial clock. What literally this what the serial clock does, it is that it is the line in which decides how the timing or the rate in which data will be transferred between the devices. So that's the serial clock. That the serial data is what is used for data transfer. So literally that is all about I2C, and there's much more. That's not all, but there's much more about I2C, but we'll be literally looking at now how to use it in in interfacing or with communication with an LCD display. Is there anyone who feels there is a question up to just that point? Anyone who feels there is a question about that point or the concept of I2C? Anyone with a question at that point? Okay, so if you have any question, you just unmute your mic and ask, and I'll be ready to respond to you. So now, knowing that this thing can communicate with I2C is the first thing, and then we now dive into how we can literally do that, and we'll be looking how we can do the interfacing in kariRS. If you are completely new to kariRS, it is literally a Rust-based embedded framework. I've heard one of you has mentioned, I mean, Sharon has mentioned that she has interacted with Rust. So this is the framework that is meant to bring a unified API for communicating with microcontrollers like the AVL microcontrollers like the Uno, the Mega, ESP32, and all those MCUs using one framework. And because when dealing with Rust, you'll find that each microcontroller family, for example, if you have the ESP32, they have their own hardware abstraction layer. The actual HAL, or a HAL is a hardware abstraction layer, is what is used to program each microcontroller. So each microcontroller family, for example, for the ESP32, they have their own. If you go to the AVL microcontrollers, they have their own. Now that difference is what makes it means that if you want to program an ESP32, you have to learn how to program it. You have to learn its syntax and everything. If you want to program a AVL microcontroller like the Uno or the Mega and the rest, if you want to do that in Rust, you have to learn the syntax, the last syntax to do that. But with kariRS, you will use the same syntax to program literally any of the MCU families. So that is what kariRS literally is meant for. So currently the kariRS version we are looking here is 1.0, which currently supports AVL with the and ESP32 support is currently in development. But at the foremost, that is what kariRS does, and it is very friendly, and it offers a high level of abstraction. So for example, if you've written programs maybe using Arduino, you'll find kariRS, it's friendly, it has various functions which are similar to Arduino, but again, it is Rust based. So we'll be now this is the official documentation. I'll share the link. So we want to check out, so we'll be checking here the API macros, and we are interested with the LCD display. So we can just move down here. Yeah, and here it is. We'll be looking at the how to interface with an LCD and the I2C protocol. So you can see in the documentation we have various functions which have been highlighted here, and we'll be going ahead and writing a program to see how all this works. I don't want to appear to be fast, so if you have any question, you can go ahead and ask. Anyone who feels they have a question on anything. If you're with me, just confirm. If you are following along, confirm. Thank you, Sharon, for confirming. Remote, are you with us? Raymond, are you with us? Okay, thank you, Norbert, for confirming. So now, so I'll share my full screen. And so while sharing my full screen, I might not see your hand gesture according to my setup. So if you have any question, you just unmute your mic and feel free to ask, and I can be able to reply to you. So uh, since we are writing or beginning a new project, let's let's build a new project from scratch. So I'll go to the terminal, and the way we build a new project in kariRS. So if you're absolutely new, we type in kari new, and we'll be using the mega board. So you can give the board we're using a mega, and the name of our project is LCD display session, like that. Then go ahead and click enter, and you can see it created a new project. So we can cd into it, LCD display session, like that. I'll open my project in VS Code. So this is how the project template looks like. So inside of here is where you write your main code. So go ahead and clear this commented code, like that. So now we can begin uh, with uh, with our program, writing our program. Now back in the documentation, we can see we've been given that there's this kariLcd class or API, which is being used for building or for creating an instance for communicating with your LCD display. It has a new function. We can see you create it by using new. So we'll be seeing how that is done. And we need two arguments. We need to give it an I2C instance, and we need to give it an address. Okay, so let's see how that one is done. So the first thing is to create the I2C instance, because it means if we have to give it here, it means we need to have generated it. So in kariRS, so I'll start by typing in a function known as gen, or a macro known as genpins. Now I don't want to be typing things that appear alien, so we'll just refer to the documentation what this is. Genpins, what does it mean actually? So we can just go up here in the documentation. Um, so that we get to see what it actually means. You can check in the examples, and actually these examples are usually very detailed. If you wanted to do anything, given all the examples here, so I just want to show you what Jenkins is actually before we write it and the various use cases. So we'll go down until we find okay, I think I've passed it. It's around yeah, here it is. So you can see in this example here, we are given the gen pins and we give it the type of pins. Now let me illustrate what gen pins. So gen pins is a macro that you tell the kind of pins you want. So it literally generates for you a pin. Instead, if you wanted to initialize an I2C instance, and the I2C instance requires special pins for it to work. You have to allocate the special pins, and it works according to the board you are using. For example, if you are using a Mega like the one we are using, you'll find that your serial data line is pin 20, or and the SCL could be pin 21. If you are dealing with Uno, you find that your SDA pin. Remember, we've seen that the I2C communicate with these two lines, SDA or SCL, and each MCU has its dedicated pins for I2C communication. So if it's an Uno, you'll find that the SDA is the pin A4, and the SEL clock line is pin A5. So this is what Jenkins does. You literally give it the name of the pin and the pin number of the board that you are using, so that it can generate for you pins, which it can generate for you the special pins required to create an I2C instance in kariRS. So that's literally what Jenkins does. So our case here, we'll be using the mega board, so we can literally go with whatever is written here in this example. So we can see even the gen pins here for Uno are written. It goes also for Nano, and the same. If it was ESP32, it goes with ESP32 has various. So for ESP32, you can use 21 and 20 and 22. So it matters on what MCU you are in. But for this example, we'll be using as written here in these examples. But so gen pins will be using SDA pin 20 and SCL as pin 21, like that. So after doing this, the next thing is to create the I2C instance. So I'm going to say let's I2C be equivalent to a function known as init I2C, like that. So this is to initialize the I2C instance in kariRS. And if you are to check, this is how it is done. After you do the gen pins, you initialize the init I2C, and so that you can get the I2C instance. All this is done before we initialize our kariLcd. So basically, most of what we'll be doing will at the beginning of the initialization will be equivalent to what's given here in the examples. So we have the let I2C, so we'll do the initialization of I2C, and with that in the kariRS we have a handle which has all the peripherals used in AVR, and it is named DP. And inside of it we have the two-wire interface communication, just as we said here in I2C communication is known as wire interface. So some of the APIs do use it to, instead of writing I2C, they use the TWI wire interface. So that is what in AVR, because behind the scenes in kariRS, for example, when working with AVR, it uses those HALs which have the which give the which expose the I2C interface HAL abstractions as TWI. So that is what will be happening. So it is TWI like that, two-wire interface. Then after that, I'll pass in the special pin, the SDA pin, because after you've named it, you can name it whatever you want. Maybe you could call it something like Hulk, or you can call it my pin, but for simplicity or for understanding, I've just called it SDA, but literally you can name it whatever you want. Okay, like that. You can name it whatever you want. So we'll pass in SDA and then the SCL. And then the other thing you need to pass here is the speed of communication. At what, remember, I've already illustrated to you that SCL, the serial clock line in I2C is what, and okay, you can see now the VS code, the Rust analyzer is analyzing the kariRS code, and it is now kicking in. And something that I need to mention, when you are naming pins, when you're giving pins in the gen pins macro, or this function, if you would like to call it a function, but a macro, you have to tell it what kind of pin it is. Is it a digital pin or an analog pin? For that, you give it a prefix of D to mean it is a digital pin, like that. And when you do that, you can see the squiggles are gone. The error squiggles are gone. Now, the other thing is in init I2C. So you have given it the peripheral handle to deal with the, you can even see, let me hover around like this. Okay, let it load. But you give it the peripheral handle for the two-wire interface. You can see it can show you this is for Atmega 2560 peripherals. It is the two-wire interface. Then you give it the SDA, the SCL. So once you pass this to gen pins, it created for you this kind of a pin. You can see it created something like this: let SDA pin, all this. So this was done automatically by gen pins, because if you didn't have gen pins, you'd have to do all that, and you had to know the correct type and all that. So this is how kariRS simplifies things for you. So then we have the serial clock line, and now we need to give the speed. Now, for most of the devices or microcontrollers, that is ESP32, AVL MCUs, or generally I2C communication is mostly done at a speed of 100 100,000 kilohertz. That's the frequency of communication that is usually used in that's a bound rate that is usually used in the I2C communication. So that is what you're supposed to pass here. But because 100 is the default, unless you want to change, if you want to change, you can just come here and pass. If you wanted to change that, you can just come here and pass anything. Maybe you want to make it 120,000. Is that 120? Is that one or any other number? It doesn't matter. So if you wanted to give it any other number, you can do that. But since 100,000 is the default, you don't need to pass it. You don't need. You could come here and pass it as 100,000. Now, if you are new to Rust or you are not used to Rust, you might wonder, why am I writing 100 then underscore then 1,000? This is a valid syntax in Rust. You can usually, if you are writing big numbers, that is thousands, you can usually separate the zeros using this underscore. But now, since this one is the default or is what is used, already the initializer knows that, so you don't need to pass it. So you can just give it none, like that. You can just type in none and you are done with that. But if you ever wanted to change or have a different speed for whatever reason, you'd just use this function sum. It is an option, so you then give it the number you want, any number you want. You could maybe tell 13 or any number you want, literally according to what you are intending to do. But most of the time you will be dealing with the default, so you just tell it none. When you tell it none, it will default to 100,000 kilohertz. So I hope you've understood that part. So literally that's how you initialize or create your I2C. So now the other thing is to now this is the point. Now we go to the LCD, so we can just call it anything. Let mute. Now let me not type that so that I can show you another something that you might end up hitting. So I say let LCD be equivalent to kariLcd new, like that. So I can say this is I2C. Now to show you the definition, if you wanted to check a definition of any function from kariRS, you'd press Control and then hover anything that you want to know. So for example, I could click Control and click on new, and it will take me to the definition of the new function so that I can see what it takes. So you can see that it takes in an I2C instance, which we have already created, and then it takes in an address, which is an option. It is optional. You can give it, the address is optional. So it means you can pass it or not. Okay, so knowing that will help you a lot. Now, in Rust, when something is optional and you want to pass in a value, you always wrap it in sum. This function you see here, sum. So if I wanted to give any address, maybe 0x03, that's a valid address, I would do that. But most of the time you do not know the address, or you do not know what the address should be. So you would just want to default to what most of the I2C LCD have. So because you might not even know the default, so you just pass in none, like that, same as we did here. So anywhere you see we've written none, it means it's something optional. So if you pass in none, you are telling kariRS use the default for that for that instance or for that API. So that is what we have literally done. Is there anyone who has a question up to that point? If you have a question, just unmute your mic and ask. If you feel you've been left behind or you're not understanding something, you could just go ahead and ask. Okay, so there's no question, then we can continue. So now we have this instance, that is the kariLcd. So once we have this instance, now we can do various things. Now, before even I continue, let me show you the various functions that exist. So we won't even go to the documentation. I've told you, if you're using VS Code, you can just click on Control and then hover whatever you want to learn about. And the integration with VS Code and kariRS is that it will take you to the definition. So we click Control and then click on kariLcd like that, and it will take us to the definitions. So we can see the various functions. There are various many functions here. Some of them you won't be using them most of the time. Just like this one, because you need to initialize the LCD. You have the clear function, which is used to clear the LCD display. You also have the write function. You'll use it most of the time. We have the set cursor function. We also have the shift display function, set cursor visibility, set cursor blink, and all these. Now, I want us to first check into these two functions, set cursor visibility and this set cursor blink. Now, if this is your LCD and perhaps you are you're printed something like hello, like that, you would see a cursor here which keeps on blinking, and maybe you do not want it there. So that is what you deal with when using that function. Let me go back to that point. When using the cursor, so the cursor is what you you will see the cursor same as what you do with your PC. You see a cursor that, for example, you can see my cursor, I'm moving it on the PC. Also the LCD has its own cursor, so that is what you configure it using this set cursor. You set its position using this one, and then you can go ahead and set the cursor visibility using this one, and we also have the cursor blink. Do you want it to blink or not? So we'll be seeing that most of the time you won't want it to blink, but if maybe you want it to blink, it's okay. So that is what usually happens. So if this is our display, we will have this. So this will be SDA, this will be SCL, maybe this, and then these others will be power lines. So this one you'll be connecting it to 5 volt of your microcontroller, and then this one will go to ground of your MCU. So this is our I2C display. This is how it will look like. So we can print hello or whatever we want. So maybe we could print something like kariLS, and then for the display we'll be using, let me just clear this. There's something I need to mention as we continue with our program, which is very important. It's very important to mention. Now, when you have an LCD display, you cannot just print whatever you want. You have a limitation. You can see its size is small. So we have various sizes, and for us today we'll be dealing with a 16:2 LCD display. A 16:2 means it has 2 rows which has 16 columns. That means you can print up to 16 characters from end to end. So if, for example, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, up to that, we could only print 16 characters in the first row, and we could also just print 16 characters in the second row. So is there someone who wants to be admitted? Let me admit someone. Shalom, you're very much welcome. You're very much welcome. So literally that's what it means to have a 16 by 2 LCD. You can be able to print up to 16 characters in the first row and up to 16 characters in the second row. So that's the limitation you have. But if you wanted to print much more data, the trick we use is that we start shifting. For example, you might have seen displays out there whereby you see characters moving from one end to the other and coming back. Those are the kind of tricks that we use in such displays, because when you find that you want to print, maybe you want to print up to 120 characters, but you do not have room to do this because you will overflow the LCD. It can't be able to display all these ones at the same time. So what you do, you start shifting the characters so that they appear like they are moving. And if it's for your business, or it's something you are showing, is a project, or whatever you are doing it, then everyone can be able to read whatever you're doing. So this is some of the tricks you can use. But when using a 16 by 2 LCD, you have to be very careful that you can only print 16 characters per row at any given instance. So you can print less, but they cannot exceed 16 at that point. So in this row, let me change this color. So this is this is your first row, and then this is your second row, and each can take 16 characters. So this one 16, and then this one 16 characters. So like that. So, and they are 2. That's why it is a 16 by 2. So if you hear someone saying 16 by 2 LCD, now you can understand what they mean. It just means that in one of the rows, because it has 2 rows, each row can carry up to 16 characters. Now someone might wonder what are characters. Let me just want to ensure that you understand everything, not just assume. Let's take this. So there's a display, so characters are like A, B, C, D, E, F, something like that. So you could have A, B, C, D, E, F, G, H, I, J, K, L. Now you have just to know that how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we could extend this. MNOP 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so that is it. So this would be 16 characters, and here you then have 16 characters. You are free to type whatever you want. Maybe you could type here hello 1, 2, 3, or maybe you are actually updating. Maybe you are getting data from a sensor. Maybe you are printing temperature data. Maybe here it's dirty. So you just need to know that you cannot exceed 16 characters per each row. If you want to exceed, you'd have to do what we call shifting, where you have to see words moving either from right to left or left to right. You can use that trick. But for now, we want to see just first, how do we even first get to display characters? So is there anyone who has a question on this spot in that part? If you have any question, just unmute your mic, because when sharing the whole screen, I might not see your gesture. Just unmute your mic and ask if you have a question. Okay, so we can go back to the program. All right, so I'll be going ahead. So LCD, you can see already I have the option. So we'll set the cursor blink. We don't want it to blink, so I'll go ahead and turn that off. So the way you do that is by lighting cursor blink off. Now we have an issue when we are doing this. Right now you might not yet see the issue because we have not compiled the code, but I want to point it out as early. When you are calling a function like set cursor blink, you will be literally changing the state of the LCD. That means if the LCD cursor was blinking, but now you are telling it that it should not blink. So literally what you have done, you are changing the state of that peripheral or that device. So when you're doing that, in terms of programming and furthermore in Rust, you need to have a variable or an instance that is mutable. Mutable means something that can be changed, whose value can be or whose state can be changed. When I initialize the LCD, it is cannot be changed. Its value is unchangeable because by default in Rust programming, most of each variable is usually constant. It is immutable. You cannot change it unless you declare it as mutable. So that is what makes Rust very different from other programming language. Because in other programming language, everything is mutable and unless you make it immutable. But here the case is different. So here I'll go ahead and make the LCD mutable like that. And once I do that, you'll finally see that there's a red squiggle. You might not see it for now, but I think you should be able to see it, but it should, when you try to if I don't add this, the code would not compile. So now, because I'm literally calling a function that is changing the state, so I wanted to set the cursor blink to off, but you can usually maybe leave it to on and see what happens. So this is the other thing that kariLcd support. I want to do method chaining. So after that, I want to take another method. I want to change the visibility of the cursor. I don't want it to be visible, so I'll make it invisible. So you can see I'm already chaining these methods, but they don't look good. So I could take this one down here, and I could also take this one down here like that, and maybe space them like that. And maybe this is just a preference. You could decide to write your code the way you want. It's just a preference, just looks neater or a bit smart. Maybe it's just easier to read. Then I could chain another method. If there was anything in the LCD, I could clear it, but literally there's nothing in there to say, but it's just for showing you that that function exists. And maybe we could light something to the LCD. I want us to light, but before we write, there's something that is very important. You need to know where is your cursor. Where is the position of your cursor? Because we have said that you can only print 16 characters per row. So you need to know where your cursor is, because at this moment we have already even made it invisible, so you cannot even see it. So you need to know where your cursor is, and because it is a bit hard to know because we've made it invisible, that's why we have a function known as don't set cursor, which allows you to set the position of the cursor. So at this position here, the first position here is usually 0. So it's like 0 0, like this is the first row and the first column. Okay, so this the first column, this one, I mean the first row here is row 0, and then this is row 1. So we use this naming convention of like the way we do with indices or arrays when we are doing indexing. we're doing the indexing from the programming. So that's how we also name them here. So we literally set the cursor to 0 like that, and then we can write something. So maybe we can say hello LCD, maybe something like that. Could literally do something like that. So we did set the cursor blink to off, then we set the cursor visibility to invisible. We cleared the LCD. Sounds kind of redundant. You can omit this one. Just wanted to show you that it does exist. You can use clear if there was anything that was in the LCD, you can clear it, and it's a good practice during the initialization of your program. Just clear everything that is then would have been the LCD to ensure that everything is just running smoothly. Then I set the cursor to 0, and then I did write this one. So this is hello LCD. Now, how many characters are these? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Remember, even this space is a character. Even space is a character. When if you skip even anything here is treated as a character. Either you write something or not, it is a character. So you have to ensure that you remember that. So I think we can first compile this is our program, see whether it works. So I'll go ahead and save that, and I'll go to the terminal. And to compile a program in kariRS, we write kari build like that. Now, if you are new to kariRS, you know it's good to mention that the first time you compile your program, it takes a bit of more time than any other compilation, because it's the first time that it's compiling it will be compiling very many dependencies that are required for your project. But then from from then on, anything that you want, or any compilation that you'll be doing will be happening very fast. The other advantage of using kariRS is that many modules are embedded in the framework itself. You don't have to keep on installing extra libraries. It has a lot in it. For example, you can see already the LCD API that we are using is natively provided by the framework itself. It is not something that we have installed as a library or something. It comes natively exposed by the API itself. That means it integrates very well with the other functionalities in kariRS. So let's wait for the compilation to happen. The first compilation takes a bit of some time, as it is compiling a couple of dependencies for your project. Again, if you have a question, maybe even about kariRS, if there's something that maybe the first time you're meeting this framework, if you have any question, you can ask in the meantime, or even about what we are discussing. So if you have a question, just unmute your mic and go ahead and ask. Can everyone see my screen clearly? Someone to just unmute the mic and confirm. Can everyone see my screen clearly? Just unmute your mic and confirm. Just unmute your mic and confirm if you can see my screen clearly. Yes, someone to unmute their mic and confirm if you can see my screen clearly. Lucy, are you with us? Lucy, are you with us? So our program has compiled successfully. So you can go ahead and uh, upload it to the microcontroller, and it is uploaded successfully. So we should see this what we programmed, hello LCD. That is what we should literally see in our display. So me show you. Is a Hope you can be able to see it. I don't know whether the camera will take it well. I don't know whether it's quite visible or not. I don't know whether you are able to see it. Are you able to see it? Well, I should cast some light on it. We are about to wind up, so I don't know whether it's the camera can see it clearly or not. Maybe shining light on it. Okay, but Maybe it's not quite being seen by my laptop's camera, but literally what we have on the display is hello LCD. Whatever we wrote in our program is what we literally have in this, and you're using this MCU here. This is the mega, so you're connecting this I2C. You can see that behind here it is using the this is the I2C module adapter, so you can see it here. So this is what I'm using, and then it displays whatever we've written. So is there anyone who has a question before we wind up? Anyone who has a question? Sharon, do you have a question? Sharon, are you with us?
Yes.
You have you been able to see what I was showing, or it is not clear?
Yes.
Was
So,
yes?
yes, I did.
Uh, okay, but okay. I was asking, are you guys able to see the lightings on the LCD, or it's also not good visibility on your side?
I was able to see it before, yeah.
You're able to see?
Yeah, but currently you're not sharing.
Okay, let me just share for a moment. I'm asking, you can see the microcontroller.
Yeah. Yes.
Let me do this. Let me just for a moment before we wind up. Just yes. So this is the microcontroller, and I'm asking, are you able to see what is being written in the LCD? Is it visible?
The 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 brightness
It's so
is
bright,
not
eh?
enough. I'm able to see the word.
Oh,
Yeah.
okay. Let me see. Because it was already displayed. Just a moment so that we can wind up. Um, maybe could let's just go to these definitions. But again, I think the issue with the camera. Let me see whether the backlighting should be good. Let me see whether it will be visible, or if not, but again, I think my camera is not able to get the clear picture of, or my laptop's camera is not being able to see it well. But again, what is printed on the LCD at this point, then you'll have to take my word for it, is that it has printed whatever we can see here. Hello LCD. Hello LCD. I think I'll take a picture with my phone and then I can send it in the group just for you guys to confirm and see that literally what we programmed here is what is what is has been displayed in the is what has been displayed in the LCD. Sharon, are you in the kariRS WhatsApp group?
Not really.
Okay, so can I share a link with you, perhaps?
Yeah. Yes.
Okay. Uh, I think I'll do. I'll drop my number. You text me, then I'll send you the link. Okay? Is that fine?
Yeah. Okay.
Okay. Me. Also, anyone who is not in the group, just text me, and then you can get to. So I've shared my number. Just text me on WhatsApp, and then I will add you to the WhatsApp group. So if, if there is no any other question, I think then we can add the meeting at this point. And before we end the meeting, okay, I would like just to know from you, Raymond, are you with us? We are winding up. Raymond, are you with us? Okay. So, Sharon, are you pursuing something to do with software or something like that, if I may ask?
Pardon?
I'm asking,
Mm-hmm.
are you in the field of computer science or something related with software?
No, mostly related with hardware.
Okay. Okay. All right.
Yeah.
Okay, we will communicate more with time. So, thank you for attending. And if you have any question, you can also ask me personally or just ask the questions in the group, and you'll definitely get answers and feedback. And even if you also want the code that we have here, or the documentation, if you want to get started with kariRS, I can also share the link to the GitHub repo. Let me just drop it right now as we wind up. Let me just drop it. So if you have any question about the framework or anything you feel that could be added to the framework is currently under more development and is a developing Rust ecosystem framework for working with microcontrollers. So feel free to look into it. It's open source, and if you also find that you could also be part of building it, it's okay. You can just communicate to me. So thank you all, and have a good evening or a good night.